Okay, so today we're going to begin this lesson by talking about placing fractions on a number line. This is going to get us into a really good place to count fractions. Our learning objective today, to count fractions. Let's begin today with the fraction 3/4, 3/4. And say we want to place that fraction on a number line, ranging between 0 and 1. So first, we've got to examine the denominator of the fraction. This tells us that we need to split our number line between 0 and 1 into 4 equal parts. Next, we just count the spaces to work out where 3/4 should be marked. 1, that's 1/4, that first marking. 2 spaces, that's 2/4, the second marking. 3 spaces, that's 3/4 at that third marking. And now we've got number 1, the whole number, which can also be marked or recorded as 4/4. Now we've plotted 3/4 onto our number line. Let's try another one. Where would we plot 4/6 on the number line shown? Consider the fraction. Really think about the numerator and the denominator. Is this an improper fraction greater than 1? Or is it less than 1? Yeah. We know that this fraction has to appear somewhere between 0 and 1. The numerator is less than the denominator, so it's got a value of less than 1. Feel free to pause the video now and have a go at home. Then just continue watching the video to see how well you get on. We know the denominator is 6, so between 0 and 1 must be split into 6 equal parts. That's maybe not exact, but you get the picture. Now, to work out where 4/6 is plotted on the number line, we just need to count our fractions, count the markers. We've got 1/6, 2, 6, 3/6, and 4/6. We've managed to plot 4/6 on our number line. Let's vary it up a little bit. What if I wanted to plot an improper fraction onto the number line? An improper fraction. Do you remember what that is? Yeah, it's a fraction where the numerator is greater than denominator. These are examples of improper fractions. They're all greater than a whole value. Anyway, 8/6, 8/6. Where would you place that on the number line below? Pause the video now and have another go at home, and then press play to find out how well you did. Again, focusing on that denominator, we know that each whole number, each whole part, will be split into 6 equal parts. We know that's an improper fraction because 8 is more than 6. So it's got to be in this part of the number line. So I've split between 1 and 2 into 6 equal parts. 1, 2, 3, 4, 5, 6. We know that 1 whole is the same as 6/6. So now we've just got to start counting. 6/6, 7/6, 8/6. We've just identified where 8/6 falls on the number line. Challenge question. What's another way to write 8/6? I want you to write it or to think about that fraction as a mixed number. Think about your whole and part models. We know that 6/6 is one whole. So what's left over? There's one whole and two parts. So it's 1 and 2/6. So here where we have 8/6 marked on the number line, we could have actually recorded it as 1 and 2/6. So how well did you do? Have you got it? I want you to consider this improper fraction here, 12/5, right? Before you give it a go, I want you to really consider, first of all, think about the denominator. What's the denominator telling you? Then look at that numerator. We know that the numerator is greater than the denominator. You've got to think, what's that telling you? And then look at the range of your number line. The number line ranging from 0 in value to 3. Okay, pause the video now and try to plot 12/5 onto the number line. It might be worth considering using a whole and part model to work out what you really need to show on that number line. Okay, first of all, how many wholes are in 12/5? Well, you've got 5, 10. There are 2 wholes and 2 parts left over. So 2 wholes and 2/5. This gives us a little bit of an idea of what we got to do with the number line to begin with. We need to show 0, 1, 2 on the number line. And next, we need to split this section of the number line between 2 and 3 into 5 equal parts. We do this because the denominator is 5. So we've got 2 and 1/5, 2 and 2/5. That second marking is 2/5. But it's actually not just 2/5, it's 2 and 2/5, because from 0 all the way up to this point, 2 wholes and 2/5. 2 and 2/5 can be recorded 12 as 12/5. I'm wondering, have you noticed actually that improper fractions can be recorded in 2 ways on a number line? Let's have a little look at that. So the 2 ways that fractions can be recorded in the number line, they can be recorded as improper fractions, where the numerator is bigger than the denominator, or they can be recorded as mixed numbers. And that is simply your whole and part model. A mixed number is where you've got the whole and part fraction beside each other. So 1 whole and 2/5, 1 whole, and the part is 2/5. So your improper fraction and your mixed number are written and recorded differently, but they have the same value. On the number line here in front of us, we've got some missing recordings. I'm going to have a little look at it. We've got 7/8. So the next marking, 7/8, going to count down. It's simply 8/8. And now already that's been recorded as one whole. You can see this here. But we know that 1 whole and 8/8 have the same value. They're equivalent. Here's the mixed number. 1 whole and 1/8. 1 and 1/8. What's another way to record that as an improper fraction? We can record it as 9/8 because it's 8 eighths and 1 more. 9 eighths. 1 and 1/4. 10 eighths. 11 eighths. 12 eighths. Look here. We have 12 eighths, but we also have a recording as a mixed number. 1 and 4 eighths. So we can actually test to see whether this is right. They should be equivalent. 1 whole is 8 eighths. 8 plus 4 is 12. So yeah, we know that 12 eighths and 1 and 4 eighths are the same. I would like you now to pause the video and find the value of A, B, C, D. The values are shown here in yellow. How'd you get on? On the top line, they're improper fractions, so we're just counting on. So you've got 12 eighths, 13, 14. A is 14 eighths, 15, 16, 17, and 18 eighths for D. Underneath, we've got them recorded as mixed numbers. So 14 eighths can be written as a mixed number because it's 1 whole, which is 8, and 6 left over. 6 eighths is the part. 1 and 6 eighths. 16 over 8. Well, the numerator is double the denominator. 8 goes into 16 2 times. No remainders, so there's no part. It's a whole number, 2. And 2 and 2 eighths, well, 2 wholes is equivalent to 16 over 8. So 16 plus 2, 17, 18. It's 18 over 8. That brings today's lesson to an end.